Good morning, Jesus. I know that the first talk usually in the second day is tough because everyone is a bit sleepy, a bit more sangria in the evening, a bit of beer. So let's start with a quick survey just to wake up. So how many of you have heard about Micro-Frontends? Raise your hand. Okay, keep your hands up, keep your hands up. Perfect. So how many of you are currently using Micro-Frontends in production? Less. How many of you are thinking to use Micro-Frontends? Slightly more, okay. Okay, that's good. So perfect. So the talk is exactly what you're looking for. So when I joined AWS 4 years ago, there is this quote from our CEO that always struck me because, there is no compression algorithm for experience. And I think this is a bit of my mantra in life and in tech. And overall, I think that when you take, let's say, the experience of a lot of engagement with customers and you collect them in a talk is always, let's say, a great way to share knowledge. Because storytelling is one of the most powerful ways that we have in order to remember things. And I'm a strong believer on that. And in fact, in this talk, I collected basically what I have done in the last 9 years working with Micro-Frontends, first in the trenches in my previous company. It was called The Zone, that probably here in Spain you have heard about it. It's a live sports streaming platform. And now in the last 4 years, I follow hundreds of customers that are building Micro-Frontends in production from Silicon Valley to Australia. So that's what I want to bring with you today. Who am I? My name is Luca. I'm a principal serverless specialist in AWS. I'm an international speaker. I had the pleasure to talk from Silicon Valley to Japan. And I'm a published author. I wrote 2 books, and I'm writing, as we speak, the 3rd one. So usually when we think about Micro-Frontends, we start from something like that. We have a monolithic UI, and we have different areas that usually we call components. And at some point, people think, okay, so perfect. Micro-Frontends are just what we had before. We just, let's say, chop it in multiple chunks, and that's it, done. Not really. That's the problem. The main problem I've seen companies failing with implementing Micro-Frontends is because they start from this approach. They think that are just components, but Micro-Frontends are not components. From this definition that I coined 8 years ago when I had to explain to hundreds of developers in my previous company what we wanted to achieve, because bear in mind, 8 years ago, the term Micro-Frontend didn't exist. ThoughtWorks created in 2016. So as you can imagine, explaining something that you have in your head that you conceptualize to, let's say, a large crowd of very opinionated engineers, because every engineer is very opinionated, it was tough. So I had to come up with a rock-solid definition that helped everyone to be on the same page. Also because we needed to have a North Star where everyone can rally behind it. So in this case, as you can see, we're talking about a few things. So let me drill down into the different definitions. So Micro-Frontends are a technical representation of a business subdomain. So when I started, I had to figure out a way that I could differentiate components from Micro-Frontends. Otherwise, the risk was creating a distributed monolith, like in microservices. When you start to tangle things together and interconnect everything, it's complicated. And therefore, the best way to find this proper division that you can create inside the system comes from domain-driven design. And in this case, we are looking from not a technical perspective. So there are 3 lines of code that are duplicated. Let's abstract it. We look into the business perspective. So let's try to understand how our users are using this system and trying to see if there is a relation between the boundaries of my microservices and my Micro-Frontends. The other thing that we want to optimize for is for independent implementation. Oh, sorry, wrong button. For independent implementation. And what I mean by that is distributed systems are designed for the organization, are not designed for customers to a certain extent. If you think about how Amazon.com is built, you probably don't care that there are bazillion of microservices behind that. What you care about is going to the website, buy what you're looking for, and off you go. But what we care, although, is that we want to have a distributed system because we create less friction inside the organization to build a large system with multiple teams and a lot of people. And we know that if there are too many interactions inside a system, that will slow down the throughput of the team. The other thing is, and that is a point that we're going to touch in this presentation, is that usually micro-frontend are built with the same technology. You can obviously use multiple of them, you can have multiple framework, but it's not the ideal approach. We will see an anti-pattern about that. The other thing is that we want to minimize the code share. This one, when I came out 8 years ago, was the most controversial part of my definition, because they started to, let's say, flood the social media with flames around, oh, Luca is saying that we need to duplicate everything. That's not the case. But we are optimizing for something different than a monolith, because we are in a distributed system. Remember that. That is a very important distinction. Last but not least, the ownership part. Unfortunately, I have experienced quite a lot of customers that are still in the mindset, oh, we build, we build our solution and the developers are just writing the code, throwing it on the other side of the fence, and they don't know how it's going to production. That is a problem, especially in distributed system. We need to understand how the things are working in production. Otherwise, we are blind into that. There are several benefits of micro-frontends. So let's start with the first one. People are looking for embracing micro-frontends for incremental upgrades. I can take a portion of the system and update it incrementally without any problem. I don't have to go in stealth mode for 18 months and then wait that everything is done, and then finally you can have a system that might or might not work in production, because after a long period of time before you hit production, a lot of assumptions might have changed. The other thing is they are great for decentralization. We have seen yesterday in several talks, when we talk about distributed system, we need to change our mindset. We need to look into decentralization. That is not only on the technical side, it's also on the people side. That is extremely important. The mindset has to shift towards that paradigm. The other thing that I witnessed with my eyes was that team cognitive load was reduced drastically. So in my previous job, we were moving from 50 people to 3,500 in 18 months, give or take. We have 550 techies in the company spread across 4 different dev centers in Europe. And there, as you can imagine, there are a lot of people that we need to hire very quickly. So I had, let's say, teams that were they knew React, they knew how to build, let's say, with MobX, and then suddenly, in less than a month, they had code that was hitting production, because they had to understand a very narrow part of the system, and then over the month, they started to learn more. And last but not least, is that we are thinking, when we are looking into distributed system, into scale not only the technology, but more importantly, the organization. Now, with that said, we have seen some benefits of micro-frontends, a bit what they are. Let's start with the most common anti-pattern that I ever seen. The yin and the yang, or micro-frontends and components, the difference between the two. So usually, the story starts like that. I have a team that is building a component. In my case, I started to take the component by definition, aka the button. So I have a button that I create a component, maybe for a design system. I can assign a label, so then I create a property for that. Then suddenly the button becomes very popular, and there is a new requirement. I want to have an icon and the label that I can set inside this button. But then the buttons start to be very popular, and they started to be reused in several areas. So now you want to have change border colors, because you need that for the rollover. You want to have different rollover animation. You want to have localization, and therefore you can auto-size the dimension of the button. And finally, you want to use the button for forms, but you want to have that disabled by default for creating that. So yesterday, one of my heroes in architecture is Neil Ford, and yesterday was saying exactly what I was talking about today. So reuse is a form of coupling. So when you're talking about components, you are looking for reusability. What you are looking for is literally, I want to take my design system and reuse across the application. That is nothing wrong with that, and you need that, but this is not micro-frontends. So when we are looking into micro-frontends, we are looking into this. We want to have, first of all, we want to have encapsulate its state, because we want to be independent Therefore, if you're sharing the state, we have a problem. Every time that we change a state, and Neil yesterday elaborated very well this concept, every time that you change something in the state, if it's global and share across micro-frontends, then it means that every single micro-frontend has to be retested. You need to coordinate every single team inside there. That is not, let's say, a smart move. So what you want to have is a state management is encapsulated in the micro-frontends. Micro-frontends is context-aware. That doesn't mean you don't inject anything, because before, with the component, all the things, all the real context was owned by the container of the component. It was just a button, and it will say, oh, if you are a form, behave in this way. If you are in this page, behave in that way. Micro-frontend knows how it should behave. They just need a bit of information, like potentially the ID of a product or the sticky session, or whatever it is. It defines very well input and output, so having a contract for communicating with micro-frontends, we see a pattern also there. And last but not least, because they are context-aware, because they know how to behave, they are less extensible by design. Doesn't mean not extensible, but less extensible. So I come up with an idea on how you can test your boundaries. So the first thing is, how can I make sure that my micro-frontend is a micro-frontend? If you expose an object with that bazillion of properties for a specific UI component, you're probably not looking to a micro-frontend. You want to reduce the API that is exposed because it's context-aware, as I said in the second point. The third point is, don't optimize for reusability at all costs. There are certain micro-frontends that might be reused, absolutely. Nothing against that. But don't work only for that reason, because otherwise you're going to design something so abstract that you need to leak the domain somewhere else, and this is a problem. And usually micro-frontends are more coarse-grained than components. In a page, in a UI, you can have like tens of different components. Micro-frontends, if you have like 4 or 5 micro-frontends in the same page, you are in a good spot. Over that, usually is a symptom that you went too granular, or you have a bazillion of teams working on the same application. That is not very usual. And last but not least, bear in mind, like any other system or any other architecture, the boundaries will evolve over time. They are not forever. When you design something, today is designed in a certain way. The only certainty that you have for tomorrow is that something will change in your system. Otherwise, your company is dead. And the business is evolving, likely so, and therefore you need to review how you are going to define the boundaries. That is not only for the front end, also for the back end. Therefore, if you find yourself in a situation like that, yeah, probably you are dealing with distributed components more than micro-frontends. Okay? So ask yourself what you are designing for, what you're optimizing for. The second pattern is called the Hydra of Learner. Sorry, I have fun with names. This is called the multi-framework approach. So ThoughtWorks defined this approach where we have multiple frameworks in the same UI, the micro-frontends anarchy. It was, let's say, it was announced in 2016. So in 2018, if I remember well, in 2019, they described that. We put on hold micro-frontends because teams started to use bazillion of different frameworks. But I want to ask you one question, to all of you. How many UI libraries or frameworks are used in a single-page application? Anyone? Sorry? 1. Perfect. Amazing. Why that? Because you know that performance matters. You know that if you are using multiple frameworks, that, by the way, technically you can. At the beginning, when React came out, several years ago, as you can see, I lost all my hair when that happened. There were a lot of people that were combining React that was just a UI library with Angular. Because Angular had, let's say, the framework behind that with all the design pattern already defined, and they were using React because it has the idea of virtual DOM that was solving the problem of reconciliation of the real DOM. And therefore, that is, let's say, something that is doable. But you don't want to do that because you know that not only the performance, but also inside the organization, you need to bear in mind that if you have like a whole organization working with React, with Vue, with Angular, then you can share knowledge, you can move people around. There are a lot of benefits of approaching that way. However, because you can have a multi-framework approach, I have seen few times when that really shines. For instance, when you are dealing with legacy system, Back in the days, when I was principal engineer in a gambling company in London, we had to migrate from one framework to another one. But we had to go to the CTO, prepare a plan, and go in stealth mode for several months, and then finally started to deliver the application. But with Micro-Frontends, you don't have to. You can start to take a portion of your system, build it end-to-end, go into production, boom. You start to create value for your company. And you do that over and over and over again. A story that we have seen very often with microservices starting from a strangler pattern. Also, when you are migrating from a new UI framework to, from an old UI framework to an old one, classic, from Angular 2 to something else, another version of Angular, this is a good approach for doing that. And last but not least, this one was unexpected for me, but I discovered a few years ago, after acquiring new companies. There was a customer in Silicon Valley that 3 years ago, they contacted me saying, listen, we have this challenge. We have like acquire a company, but unfortunately, they're using a different stack. How we can combine everything together because we want immediately to capitalize our investment. And that was a good approach for that. So when you think about multi-framework, don't optimize for that. There are companies that I follow that at the beginning they say, oh yeah, listen, Luca, we want to optimize for that, but a system is not a playground for developer. A system is something, the code that you're writing is for creating value for your users, for your customers. It's not for the amusement of the developers. Create a pet project if you want to try bazillion different frameworks, but don't pollute your code in production. Now, the next one is the Swiss Army knife for writer programs that do one thing and do it well. So think about Unix. So we created like a lot of programs that can be combined together, and that was the initial thought about that I really like it. I think it was fantastic. So when we are thinking about that, let's assume this scenario. So we have a greenfield project. We decided to go with Micro-Frontends. Great. So we have an application shell that is the dotted rectangle that is loading a Micro-Frontend. Great. And then we discover another domain that, for instance, a classic one is my account that require maybe payments UI and also user UI that usually are different teams that are handling that. So you combine them together. You decide that for communication you're using a pub/sub pattern, therefore a custom event for communicating. So you already set up a very strong foundation for your system. And last but not least, you use the local storage for your, or a cookie for your sticky session. OK, perfect. So now an acquisition comes. You have a legacy editor or, let's say, an acquire editor that you want to integrate there. What I have seen over and over and over again is that people start to take the legacy editor, put in an iframe, and then start to communicate between the application shell and the iframe using post message, for instance. And that is a problem, because that means now you start to have the application shell that knows that an iframe exists in the system and also has a different way to deal with the new part of the system with the other Micro-Frontends. But let's try to steal from like proper artists from other architectures. Anti-corruption layer to the rescue. What we can do is wrapping our legacy editor inside an iframe, but also wrapping the iframe inside a container that the only thing that it does is sanitize the communication between the application shell and the rest of the application. So the application shell remain exactly as it is. We want to minimize the changes there because we know that it's the entry point of our application, and every time that we change that, we need to do a lot of testing. Therefore, anti-corruption layer works perfectly. It aligns very well with our architecture decision. That means if tomorrow I start to carve out functionality from the legacy editor, and I start to build my own Micro-Frontends in the stack that I wanted, that then I don't have to change the application shell. It's just loading a different Micro-Frontend, and that's it. So even more rock solid. And it's ready for the future. The moment that I fade out the legacy editor, it's not a problem anymore. So bear in mind that application shell is the most critical part, and the rule of thumb to understand that you did a good job there is that the less time you change the application shell after releasing in production for a few months, because at the beginning you have a few iterations just to tweak things here and there, the better it is. And anti-corruption layer is something that you need to think about, especially when you deal with let's say, systems that are outside your control. Oh, this one is very cool. So this one is another anti-pattern that I've seen, unfortunately, too often, that is unidirectional data flow. So in Micro-Frontends, you usually have something like that. Module federation is one of the, let's say, possibilities that you use for building Micro-Frontends that allows you to have a host that is a container of Micro-Frontends and a remote that is a Micro-Frontend. And what you can do is saying, oh, dear host, I expose the entire system with Micro-Frontends, so the host can load the Micro-Frontends remotely at runtime. Great. But unfortunately, the host can also expose a portion of itself and hand it over to the remote. So when you start to do this bidirectional sharing, then you get in trouble. So I'm coming back in the days, I started as Flash developer, where there weren't all the fancy frameworks that we have nowadays in JavaScript, but we work a lot with the MV star architecture. And I can guarantee you that when you deal with a system with multiple teams that you're using an MVC or an MVVM or an MVP architecture, usually the presentation model, the controller, or the view model is starting to get leaks of other layer of our architecture very quickly, and therefore it became very unmaintainable, because when there is a bug in production, you start to say, okay, so where it is? Oh, it should be in the model, but it's in the controller. How does it work, this part? So therefore, in front end, back in the days, in 2015, it's almost 10 years, there is Facebook that came up with this idea of unidirectional data flow. That is brilliant, because now we have a single way to update our view. This is like Flux. There's like an old screenshot that I took back in the days. Flux was the first state manager for React. And the idea behind that is I click a button on the UI, there is a dispatcher, the action picks it up, and update the store, update the view, done. And that will stress even further when we talk about MVI, model view interaction. And the cool thing of MVI is completely reactive. So it's embraced very well in the Android community. So if you're using Kotlin, probably you know what I'm talking about, but also in JavaScript, there were quite a few libraries on that. The idea behind that is, again, simplifying the cognitive load for developers. I know when there is a click of the button that goes into the intent is updating the model is updating a view, and finally arrives to the UI. And it's very easy if you have this, let's say, separation of concern to understand where to fix problems. And if you are passionate of reactive programming, I wrote a book on that, so I'm quite passionate about that. That was fantastic, because you usually use like a subject or a reactive stream, depends which library you're using, and you can, let's say, even manipulate the data inside the pod. That was brilliant. Therefore, in this case, remember, if you embrace unidirectional sharing and data flow, it's easy to debug. Very often I've seen these things failing because, oh, we need to rush to deploy this stuff in production. But the problem is rushing in distributed system. It can work once or twice, but then you accumulate technical debt that you need to smash at some point. And then definitely it's less prone to error because you know how it works. So avoid bidirectional sharing, despite it's doable, unless strictly needed. Oh, now, one of my favorites that is touching tech and organizational structure. So relax is just code. This is what we call in microservices design time coupling. Would you do, let's say, would you create like a single database for multiple services? Maybe not in microservices, because you know that if you change the schema of the database, and then you need to retest everything. It's exactly the same thing here. If you have a global state, you're pretty much screwed, because in the long term, you're going to, every time that you update the new Micro-Frontend in the system, you are creating design time coupling between the different teams. It's a challenge. We have seen that in microservices. Bear in mind, microservices are there since 2005, the first inception. So we have learned a lot of stuff from there. And an event emitter or any pub/sub pattern that you want to use, if you want to use a reactive stream, if you want to use custom events, is fine. My favorite one is an event emitter because it's simple to understand. It doesn't rely on the DOM structure like custom events, because you can intercept an event and block it potentially, and you need to understand how the DOM tree looks like. But an event emitter is extremely simple. It's just literally a way that you have, let's say, a subscription for a specific event, and who is interested will pick it up and react to that. It's exactly the same thing in event-driven architecture. What you want to have is a pub sub, or you want to have a broker that is enabling you to communicate but decouple the different systems. And because, as we said before, we don't go too coarse grain inside, fine grain inside my UI, therefore we are not going to have bazillion of micro-frontends in the UI. This communication will happen only between 4 or 5 elements. But if I need to plug a new micro-frontend, easy peasy. I just add it, even in production. It doesn't listen to anything, no problem. It dispatches an event, no problem. There won't be any JavaScript error inside your console. It will just flow normally. You dispatch an event, no one is listening, not a problem. But if you change a string to a number in a global state, then probably you have a problem. And you can even impair the usability of your application. Therefore, remember that you need to embrace loosely coupled but highly aligned micro-frontends more than coupling everything together. OK, this one was completely unexpected, I can tell you. This one, I never expected that something like that happened, but it does. So multiple micro-frontends calling the same endpoint. So imagine this situation. And usually it happens when you have a scenario like that, when you have what I call horizontal split, so multiple micro-frontends in the same UI. The reality is this one is by far the most difficult one. Vast majority of my customers start with what they call vertical split. So they take one single page or multiple page or group of pages and assign to a team and job done. When you have a scenario like that where you have multiple domains inside the same UI, then you need to really think how you're going to design the interaction, the governance, and stuff like that. It's not just the tech part. So in this case, the 2 bottom micro-frontends call exactly the same API. There usually is not authentication. Authentication is normal. There are companies that are building a library and sharing between micro-frontends for the authentication. So if we have a micro-frontend that is spread across multiple UI, or they are centralizing the application shell. My favorite approach is centralizing in the application shell, but it depends from what you are building. So in this case, you have these API that are calling. These micro-frontends are calling the same API. But the problem is you don't often, especially if you're not working in cross-functional teams, but also if you're working in cross-functional teams, it happens that you end up in a situation like that. You have 2 calls that are currently hitting an API gateway, wherever API gateway you want to use. OK, that's fine. The API gateway is there for exposing an API, handles quite a lot of calls, fine. But then, obviously, there is also an authorization service. So now you add 2 calls to the authorization service on top of all the others that you already have on the system. OK, you authorize. Finally, you reach your API. Job done. You get back the response, and it's easy. The problem is we are in a distributed system. It's likely, depends how it's designed, obviously, if there is no cache on that microservice, if the microservice is not self-sufficient, if it's an orchestrator or whatever, you start to call another API and another API and so on. Now, I had the pleasure to work in many systems, but the most challenging one was when I had to deal with live sports streaming, exclusive rights for a specific event, like a Super Bowl or, I don't know, a Liga match like El Clasico. And there we moved from 10,000 requests per second to 2 million in 1 minute. And designing for that scale is not an easy task, because you need to build everything around that minute. And the system has to cope up for that specific minute. So if you are on top of that, adding additional calls and strain to the services just because you didn't do your proper homework for designing the system, we have a bigger problem. And therefore, it's very important that you look holistically on how the system works, because otherwise you might discover that it's not going to be a pleasant day for your backend developers. So possible solutions. When I see usually a situation like that, the first question that I ask is, are we sure we are in front of 2 micro-frontends? Maybe the boundaries have changed. Maybe the system evolved, and then suddenly these 2 things that before were separated, we need to create a single micro-frontend. That could be an option. But now the second option is more interesting. We said that components are leaking the domain, right? And if they are leaking, let's leverage that. It's a design capability. So if I have 2 micro-frontends, potentially I can convert one as a component, and also the other one as a component, and have one single team that is owning that layer that contains both components. That layer of the micro-frontends will handle the request to the server, so single request, and will feed in to the props of the components. As you can see here, there are 2 things that are important. First one is that we are leveraging components inside micro-frontends. That is totally doable. So don't be afraid of that. Remember, components, ideally, you build so you compose at build time, not at runtime, like you would do with micro-frontends, because it became easier to test and handle with that. And also here, you can maintain also, if in the previous one, probably you will assign all the single micro-frontend to a single team. In this case, you can maintain the separation of your teams in a way that will enables you to create, let's say, 2 components that are handled at build time, and then the only thing that you need to deal with is a bit of governance to understand when there is an update of component, how you can do that. And there is a trick over there. Very often, for instance, a situation like that manifests when you have a design system. And one of the questions that I had several times is, look about, OK, so we have distributed system on the front end. How can we handle design system? Because we need that in order to have consistency inside the UI. Totally true. But people are afraid that maybe a micro-frontend is outdated for a version of the design system. But what you can do is using Dependabot, for instance, and you configure inside GitHub, GitLab, whatever it is, for automatically updated the dependency that you care. And it's up to you to define how nasty you want to be with your developers. You can do like opening a PR overnight, and let's say the day after the developers see a new PR for updating the design system. It could be that you block the build in production. So before it hits production, you block it because you spot inside the package JSON that there is something. The fitness function that we were talking yesterday with Neil, all these kind of capabilities are usable also in this situation. So you just need to, personally, my preference is shift left as much as possible, because the developers has a faster feedback loop. For me, it was mandatory in general that I cannot have a pipeline that was longer than 5 minutes to deploy in production. If it was longer, I block the team till they fix that problem. Because the feedback loop for developers is the most important thing that they have to enforce certain characteristics inside our system. If it doesn't work, I can guarantee you I was one of them that finds a way to overcome that issue. And then we start to have ephemeral environments, different environments that are not the one that are going to release in production, and then suddenly everything will slow down. So in this case, understand the end-to-end impact of your decision. Now, the last but also the most interesting one. Iterative deployment. You have no idea how often I have worked in a situation like that. I create a new application, and I cross my fingers, close my eyes, and I hope that everything went well, and I deploy in production. In front-end, in 2024, is extremely common. This is how you do migration. This is how you do deployment of an existing version of a system. This is what you do everything. But when we think about micro-frontends, as we said, we start to have a completely different approach. But there is a way to do that correctly. So I have, let's say, customers that try to, in a situation like that is the most difficult one, to take, let's say, a portion of the UI and carve it out, create a micro-frontend for that, and put inside the old system. That usually slow down everything, because you don't have a real benefit of doing micro-frontends, and at the same time, you have something just to prove that works, but it doesn't work as expected. But there is a better method. So you can start to use the migration strategies by path. And this is, for me, the easiest way in wherever way you are slicing your micro-frontends. Because if you take the time to rebuild even a single page with multiple micro-frontends, or a single micro-frontend, that is in this case /catalog, the only thing that you need to do is intercepting the request. There are bazillion of CDN that allows you to have some compute at the edge, or you can configure Nginx or whatever other system you're using for routing, or you can even define through the DNS on different origin on the CDN, whatever. And then slowly but steadily, you start to build your different micro-frontends and migrate portion of the page slowly but steadily. That has a big advantage. So if you deploy like before the catalog and you still have the old system up and running, oh, the catalog doesn't work. Your fallback, it will be switching the DNS into the old system. So you always have something that works. And it will helps you to slowly but steadily, iteratively change your system. But I wasn't happy, because this is a problem that everyone has in migration, but everyone has also when the system is up and running. So I spent, let's say, roughly 10 months working with the major contributor on the Micro-Frontends community, the creator of Single SPA, the creator of Module Federation, and the creator of Open Components. And we spent time thinking, OK, how can we solve this one for all? Because it is not possible in 2024 that we are still dealing with this problem. So we came up with a JSON schema that is embraced and discussed by all the major Micro-Frontends framework creators. And then in AWS, with a bunch of colleagues, we created this. This one is completely open source, so you can download now and use and deploy in your AWS account. If you're not using AWS, you can check the code, replicate that, and publish in your cloud, on-prem, whatever it is. And this one is a solution that enables you to do canary deployment and blue-green deployment for micro-frontends, and also single-page application, server-side rendering. It doesn't matter where it's rendering. It will work if you apply that on the edge, if you apply on the server side, and so on. So this, for me, is, let's say, one of the cool things that we have achieved last year as a community. And it works this way. So this one, there are a bunch of icons from AWS services. But overall, the idea of this solution is that it's completely serverless. So you pay for what you use. If there are no calls to this service, it's not a problem. This service will work without any issue. And usually we're split in two ways. So we have the first part where you see all the blue icons that are DynamoDB tables, so a NoSQL database, completely serverless, that we have in AWS. That is your back office. Everything that is on the left of that icons is basically your back office. And it works in this way. So we expose a bunch of APIs. These APIs are pluggable inside your CI/CD. Are you using Circle CI? Are you using, I don't know, Jenkins? Are you using GitHub Action? Doesn't matter. At some point, you deploy these services in production. It could be inside a container. It could be inside an S3 bucket, or whatever it is that you're going to store in a CDN, wherever you're storing your micro-frontends. So we collect this thing. The only thing we ask is, tell us when you deploy something new. Tell us the version of the micro-frontend. Tell us your deployment strategy. Do you want to have every every minute, 10% increase of that specific micro-frontends? You can do that. You want to do a blue-green deployment, so you have both versions available, and slowly but steadily you migrate. You can do that. It doesn't really matter, so it's completely up to you. You need to do a rollback very quick. You can deploy all at once. And the beauty of this approach is that we take care with the pink icon at the bottom, that is step function. Step function is a serverless service that basically is an orchestrator. And based on your specification, we just update these tables, that then we update the final table that is called consumer view store on the right of this diagram. The only thing that is going to hit your in production is the three icons that are on the center of this slide. So you have like an API gateway, a Lambda function, and DynamoDB store. We heavily optimized the DynamoDB store in order to have a linear big annotation, and therefore it's very fast to respond. And bear in mind that DynamoDB is coming out from the experience that we had in Amazon.com. So when Black Fridays or Prime Days are hitting a lot of DynamoDB tables. And this one for us is a solution that quite a few customers are currently implementing. You can open a PR if you want, adding new functionality, whatever, but it's something that definitely we need. In one of the many talks that I deliver on this topic, specifically in this one, was with my colleagues, and we were basically discussing about micro-frontends, but also I showed a demo in production. So while I was talking, I was deploying a micro-frontend that in 10 minutes, basically, slowly but steadily, was doing a canary release on that. So I can show and prove that people can use this without any problem. OK, so here, the key things is you need to create a safe net for your developers. I truly believe, and I have experienced that when you have like the right mechanism inside production, the change advisory board or any other, let's say, layer that separates the code from production can be dismissed and disbundled. Because the reality is, if you create a safe net for developers, you start to see not anymore a lot of rollbacks, a lot of issues, because there are incremental and small deployments. I give you this idea. So when I started to do that before, so back in the days, we were doing in the zone this stuff on the edge, and we started to have a lot of, let's say, micro-frontends that started to flow into production. The problem we had is that the developers had to go through different process. But I said, OK, listen, a lot of stuff, especially for certain areas, were small tweaks. And what I wanted is a fast feedback loop. So we had the possibility in our previous system to intercept a request, understand from which country it was coming from, so geolocalization, understanding the browser, and the developers can say, I want 5% of this new micro-frontend, 5% of traffic that eats these new micro-frontends. And with the observability we had in production, we can test live video player, the video player with live content in production in a specific country. And we could change things on the fly. The developer feedback was, I never seen a rollback in that situation. We moved from 4 deployments per month to 25 in the first day. That was crazy. Because the developers started to say, OK, but even if if there is an error, the error is minimal. It's like I'm eating, I don't know, Switzerland, that back in the days was the smallest country we had with customers, on Monday morning that there is nothing live, and I can start to see a bit of people that are using and see if the, let's say, the parameters of my, and the data from my video player are working as expected. And I found that extremely powerful because developers finally changed the way how they were thinking, and they started to be more, let's say, prone to deploy in production, knowing that they're not going to break anything massively. Nowadays, so I met with a few principal engineers literally a few months ago from the zone, and 8 years later, they're still using the same architecture. And as you can imagine, despite front-end and back-end, 8 years with the same architecture, enabling them to continue to innovate and maintain the quality that we had is a huge achievement. So I want to leave you with this. What you have seen, obviously, is in the trade-off analysis that Neil explained yesterday, is this selection was already made. Like, we have distributed system. We want to use that for scaling our organization or for using multi-tier architecture. But you need to think about trade-off. In modern architecture, doesn't exist, let's say, the best practice. I was a developer that back in the days, extremely opinionated, and started to say, oh, yeah, because this is the design pattern. There is no such thing. You need to understand your context, and you need to have a balanced approach based on what you need to achieve. And very often, I have seen, let's say, mistakes made not only in micro-frontends, but in general in architecture by, let's say, companies because they didn't understand their context. They are just applying blindly something that was working in another company. It doesn't work like that because we know that we are unique. And therefore, we need to understand how we behave, what are our, let's say, governance process, what is our governance process, what is, let's say, the way how we are, in general, working as a company, what we are trying to achieve, what are the business goals, and so on. Otherwise, unfortunately, don't blame the architecture because it's not an architectural problem. That's all I got. I hope that you enjoyed, and we have a few minutes for questions.
Thank you so much, Luca. We indeed have dozens of questions. So hopefully we'll have time to answer a couple of them. And we'll just start straight away. Regarding the global state coupling, how about having Redux misused as a global database?
Redux is an interesting one. It still, let's say, has the same issue that you would have with any other global state. So the pattern applies also to Redux. Between Redux and other, let's say, state management, MobX for me is the one that MobX state tree, that's the one that works the best. Nowadays, ZooStand is another interesting one, and a few others. But I would say if you're thinking to create, because it's Redux, a global state, you might have the similar problem if you don't play very careful on how you're going to update. You create a governance around that, stuff like that. I'm not saying it's impossible, but it's more difficult. And friction usually is a symptom that something inside your system or a design decision is not providing you what you expect. And therefore, you need to revisit that decision at some point.
Thank you. You mentioned 5 minutes to the production pipeline. Can you share more? I have seen pipelines taking 3 hours to 9 hours.
Sorry, can I see that? You mentioned 5 minutes of production. Can you share more? Okay. Yes, so Micro-Frontends usually, so it depends. There are a few things. Usually in monorepo, you have more challenges because at some point, it starts to grow immensely. And unless you start to do your homework properly, we have seen cases like, for instance, Google or Meta that created their own system for handling massive monorepo. So we know upfront that there might be some challenges, so you need to invest time. Now, for me, it's not acceptable 3 hours for a simple reason, and is not even a technical reason, it's a business reason. So if I have like 3 hours for building something and then deploy, it means that I can deploy and roll back twice in a day. That's it. It's gone. So you basically have a business bottleneck that is not technical at all. Yes, it's manifesting as a technical issue, but it's a business problem. And for me, you know, with Micro-Frontends and any distributed system, you need to invest that time and explain to the business that that is what they're paying for. If you have a very highly rate service that can be changed iteratively quickly, then the business can start to have what distributed systems are promising. Agility, time to market. The only thing that they care about is that part. You need to touch their wallet, basically. Because the reality is, this is, yes, a technical problem, but that is manifested not only on the technical side, also on the business side. Because 9 hours, it means that you deploy once, and then the day after, 9 hours is even better. So I deploy today, and tomorrow I roll back. So I think we understand that there is a massive problem. That it might be that in a specific area, you don't care too much, but I struggle to see that in many companies.
Thank you. Did you think about how to implement Micro-Frontends pattern for mobile application?
Amazing. Great question. So mobile, can we do Micro-Frontends? And the answer is yes, but with a specific stack. So if you're using React Native, and you're using module federation, you can. So there is a project that was created by Netlify called RSPack. RSPack is another bundler that now is using Repack. Sorry, here we are. Repack. So that project basically enables you to bundle your React Native application using Webpack. And Module Federation is a library that works with, the new version works with Webpack, RSPack, Vite, and they are working on ESBuild. And what you can do with that is basically the library allows you to handle the dependencies, common dependencies across Micro-Frontends, so you load them once. But moreover, also enables you to remotely fetch JavaScript chunks. And that means that if you have, let's say, a mobile application that just has an application shell that contains maybe the bare minimum you need, you can load remotely your part of the system or mobile system, and you don't have to go through the process of bundling a new application, wait that your customers are downloading the new version, that in my experience is the part that people underestimate. Even in large organization, it takes between 2 or 3 weeks to more than 1 month to have, let's say, a large amount of users that are receiving the new update. Instead, in this way, you bypass completely the mechanism, and you just deploy a new version on a specific endpoint, and all the mobile application will be updated. So that stack usually works, and I had a few customers that are dealing with that.
Thank you. And I would say the last question would probably not the last one. Which framework has the best trend of future prospect? Angular, React, any other?
The cool thing is that we are talking about architecture here. Framework is just an implementation detail. You want to use React, Vue, Angular, all of them will work. Because very often I heard developers saying, oh yeah, I'm designing an architecture, it's React Redux. Unfortunately, all the decisions on the architectural side, design side are taken already by someone else. You're just plugging the system. Here you are designing architecture. Here you are deciding, I want to use this UI, and I want to use, I want to leverage this, knowledge for designing my system, how to understand the governance, how to understand how the different micro-frontends are communicating together. So there isn't the perfect solution. You can use from solid.js to Marco on the server side. It doesn't matter the rendering that you're using. You want to use on the edge, you want to use on the server side, you want to use on the client side. It doesn't really matter. Here we are talking at the architectural level, so you can use whatever you want. One thing that, let's say, the new built-in functionalities for server-side rendering that we are going to have soon, Vercel announced that they are going to have micro-frontends as first-class primitive inside the next version of Next and the Vercel ecosystem. Astro is using Astro Server Island that is currently an experimental feature for basically achieving micro-frontends. I'm working with that as we speak. And Module Federation or Single SPA are great libraries that enables you to compose your micro-frontends at runtime. So here, really, we go back to the whiteboard and doing the work of a front-end architect, like back in the days when we were doing with other solution. The time of just plugging libraries together with micro-frontends is finished.
Thank you, Luca. Big applause. Thank you. Thank you. Thank you.